Okay, I think we can possibly do 20, 26, and 27 because they all cover the same thing, which is linear regression or quadratic regression or cubic regression. So we're going to go ahead and just do all three of those together because they both, well, all three of them ask the same question. Let's look at 20 for number 20. And I'll scroll back to it. It says, which set of data would best be modeled with a linear function? And I have two sets of data for you. With these three, basically, you have to do a calculator exercise. And I have a number of steps here for you. So if you want to take a minute and write these down, step number one is to clear your y equals. So you need to go to your y equals and make sure no equations are written in there. Step number two would be to press second and your y equals and press number one. Then once you press number one, step number three is to select on. So make sure that the on is the one that's highlighted. And I'm about to go over these steps with you on my computer so that you can see how it actually is happening. Step number four would be to press stat, and then you're going to press number one. Then what you're going to do is you're going to input your values. So in other words, those tables, well, your first set of table, we'll do each one separately. You'll input it. Then what you'll do is you'll press stat. You'll scroll to the right to where it says calc, and you're going to select number 4 and press enter. Then after that, you're going to create your equation with the data that it gives you, and you're going to type that equation into your y equals. And then once you do that, you'll press zoom, number 9, and it will give you your points. So in a minute, I'm about to go over this. And remember, if I'm going too fast, let the substitute know or whoever is in charge of the computer so that you can pause, or yeah, they can pause the computer and you can finish writing the steps down. Okay, so if we look at number 20, here's my calculator right here. The first thing is to make sure your y equals is clear. It is. Your second step was to press second and then your y equals. So this should pop up and we want the first choice, which is number 1. At that point, when you clicked on number 1, I said you need to make sure that the on is the one that's highlighted. So I'm going to make sure that it is. So I'm going to press enter. So now it's highlighted, as you can see. Okay, so once you do that, I said to press the stat button and make sure you press 1, which is the edit. Then what you'll do is you'll input your values. So for the first set of tables, it's 1, enter, 3, enter, 4, enter, and 6, enter. And then you're going to go over to the right-hand side for list number 2, which are your y values. So you're going to press 4, 8, 9, and 14. After that, I told you to press stat one more time. Scroll to your right to calc and press number 4 for linear regression. When you do that, that pops up and you're going to press enter. So now this is giving you your values right here. Your A, in other words, it's your slope, and that's this value, 1.96. Your B, which is your y-intercept, is 1.88. So what you're going to do is you're going to type this equation into your y equals. So if you write it into an equation form, it'll be 1.96x plus 1.88. So that's exactly what I'm going to do. 1.96x plus 1.88. Then what you do is you press zoom and then number 9, and that is the line that it gave that we typed into the y equals, and those dots are your points that were plotted from the table. So as you can see, those points are pretty close to the line. So that means that for that first set of data, your line and your points are pretty much in a straight line. So that piece of data would be a good linear function. It would be a good model for a linear function. Okay, what I'll do now is I'll go ahead and go to my list again, because as you can see, this one right here did work for a linear. Let's see if this one right here works. So we're going to type this new set of data, and everything will be the same now at this point. So what you need to do is just change your list. So what you need to do is press stat. Once you press stat, we're going to click on 1 because we're going to edit our list, and we're going to go back and retype everything. So 7, 5, 8, 10, 13, and then if we go to the other one, it's 15, 19, 14, 18, and 25. Okay, so as you can see, we have that. Then we press stat, scroll to the right for calc. Then we go to linear regression, which is option 4. Enter, and it will give you a new linear regression. So we're going to need to form a new formula. A is 0.92 and B is 10.24. So my equation will be 0.92x plus 10.24. So 0.92x plus, I forgot what I said, so what I'm going to do is go back to a 10.24. Okay, so 10.24, there we go. And what I'll do now is press zoom and option number 9, and look at that. Your points are all over the place, and they're not at all close to your linear line. So if you go back to your question, it says which set of data would best be modeled with the linear function. The one that produced the points similar, well not similar, but almost relatively close to the line was this first set of data. So we would select this one. Okay, and this one right here would be out of the question. Now if we go to 26 and 27 says which type of function should be used to model the data. So let's go to that one. Here we go. This is 26, and then I forgot to number 27, but 27 is this one. Okay, 26, we have all of these values right here, so that's exactly what I'm going to type in. So what we need to do again is change the list. So we'll go to stat, click option 1, and we're going to edit that list. So for our new set of data, we have 160, 180, 200, 220, 240, 260, 280. Okay, then we'll go back to list 2 and say that is 126, 103, 82, 75, 82, 40, and 20. All right, so we've done that, and we'll go to stat again, calc, option 4, linear regression, press enter, and we have this part right here which says it is A is negative 0.79, and then B is plus 249. Let's say 9. All right, so what I'll do is I'll type it into the y equals. So I have negative 0.79x plus 249.9. We'll press zoom, option 9. Something's wrong, so let's check. Let me see if I can go to it. Oh, I pressed a subtraction. It should be negative. Okay, so there we go. Press zoom and option 9. And that's our option right there. What do you think? You think it's pretty close to it? I agree. So for the for this set of data right here, I would say that a linear function would be pretty good for it. Now let's go to the next set of data, which is this one right here. We have a new list of data. So let's go ahead and go to Stat, Edit, and change this data. So I'm going to delete. Okay, so list 1 is -3. -2, -1. 0, 1, 2, 3. Go to the next one, and we have 3, -8, -7, 0, 7, 8, and -3. Okay, so after that, what we'll do is we'll click on Stat, go to the right on Calc Mode, Linear Regression, and press Enter. So now we have this, which is A is 1 and B is 0. So basically we make our new equation. It's 1x plus 0. So we have 1x plus 0. If you want to type that in, click on Zoom, option 9, and we have that. Obviously, that is not a good one. But as you can see, it's not even going to be quadratic because a quadratic is a parabola. So let's go a degree higher and say it's going to be cubic. So what I'll do is I'll go to Stat again. And this time I'll go over to cubic, which says which is option number 6. So I'm going to press Enter. I'm going to press Enter again, and it's going to give me these values. It's going to be in the form ax cubed plus bx squared plus cx plus d. And it's giving you the values already. It says that a is -1, so I'll have -1x cubed. B is 0, so I don't even need to include b. C is 8, so it'll be plus 8x. And d is 0, so I don't even need to include d. So I guess we'll go back over here and retype it as -1x cubed plus 8x. We'll press Zoom, option 9, and we'll see if cubic works. I think it does. So as you can see, my points that the values that I inputted are fairly close to the actual curve or the polynomial that I typed into the y equals. So for this one, I would say that the best model would be a cubic function. Now, obviously, like the one that we did earlier, that was a parabola. So if let's go back to, what I'll do is I'll go back to this one. For number 20, this was a parabola, and I'll show you, and I'll do, instead of a cubic regression, I'll do a quadratic regression. So I'll retype it again for you. Let me go to Stat, Stat, and change my values. So for here I have 7, 5, 8, 10, 13. Delete, delete. And then here I have 15, 19, 14, 18, 25, and delete, delete. So we'll do a quadratic. Enter. And it's giving you values for it. So it's going to be in the form ax squared plus bx plus c. So I'm going to have 0.41. So 0.41x squared plus, well, actually it won't be plus because this is a minus. So minus 6.49x. And then plus c. So plus 40.84. So here we go. Type it in. 0.41 x squared minus 6.49 x plus 40.84. Once you type it in, Zoom, option 9, and as you can see, this one is a lot better for a quadratic one. So most of the points, let's see, 1, 2, 3, 4 are very close to it, with this one being a little bit off. But I would still think that a quadratic one would be best for this one. Okay, so that's 20, 26, and 27.